Let's take a look at question number 2. Number 2, a particle moves along the x-axis, so that is velocity v at time t for t's between 0 and 5 inclusive is given by v of t equal natural log of t squared minus 3t plus 3. The particle is at position x equal 8 at t equals 0. So it means that initial position is p of 0 equal a, or x of 0 equal a. The question still wants us to use the x instead of p, but if you're not used to x, you can just put p of 0 equal 8, and later on we're going to replace it by x of 0 equal 8. Just make it easier. Now let's take a look at part 8. Find the acceleration of the particle at t equal to 4. So a, we have to find a of 4, acceleration at t equal 4. So we know that a of t equal to v prime of t. So therefore a of 4 equal to v prime of 4. So we already let y1 equal to ln of x squared minus 3x plus 3, and then we made y2 equal to d dx, y1 x equal x. So this is v of t, and this is a of t. So now that's our v of t and a of t. So always change the window in the beginning, because we may forget. We get 0 to 5. So we put 0 to 5, and then counted by 1. And over here, you can change into any number you want to use. You can put -5 to 5, or later on you can adjust the window. So let's use the -10 and 10. Now we are going to calculate a of 4. So in our main screen, we're going to do y2 of 4. So we're going to vars, y vars, and then we press 2, and then we got y2 of 4. So we got 0.714. This is how much you have to show. This are behind the scene. You don't need to write. Now let's take a look at B. Find all time t in the open interval 0 to 5 at which the particle changed direction. So keyword will be change direction. So change direction happens when v of t change sign. Because we know that if a v is positive, it goes to the right, and if v is negative, it goes to the left. So therefore, when v change sign from positive to negative, it changes direction. And the questions are during which time interval does the particle travel to the left? So we know that if a v of t is negative, the object or the particle travels to the left. So before we know when it's going to be positive or negative, we need to find when v of t equal to 0, when it stops. So now we are going to find where the v of t equals 0. So we're going to make the ln t squared minus 3t plus 3 equals 0. And because we had to use a calculator to solve, so now we just have to graph it. So we already have this, and we got our window. So let's graph. So it looked like it passed through and then it go back up. There are 2 zeros. But if this is not clear to you, so you can change your window. I show you before you can use zoom, but sometimes zoom fit may not be very clear to you if the graph is so close to the x-axis. So let's take a look at here. It looked like if I made the y max is 4 and the y min is -4 would be good enough. It would cover. So we're going to go back to -4 and 4. And I graph. Now we get a better graph. If you find that it's not clear enough, then you can do it again. So let's say maybe 2, -2. Now even better. All you have to do is adjust the y values. Now we're going to sketch the graph as our work. So 0 to 5. Okay. So it doesn't have to be perfect. So we just sketch it. Now we are going to find our zeros. So we get 2, and then we're going to find our first 0. Which is at 1. And then you do it again. Which is at 2. So this is the graph for v of t. So we get positive, negative, positive. So v is positive before 1 and negative after 1. Until 2, it changes to positive. So we say that the particle, okay, change direction at t equal 1, t equal 2, because v at t change sign at t equal 1 and t equal 2. So we finish the first part. And then because v at t is negative on the interval from 1 to 2, so the particle moves or travels to the left on the interval 1 to 2. So we finished the question part B. Let's take a look at C. C. Find the position of the particle at t equal 2. So part C, we have to find the position. Find p of 2. And also it means x of 2. So we're going to use displacement plus the initial position. Displacement plus the initial position. So the initial position will be at 0 equal 8. At t equal to 0, p at 0 equal to 8. So we begin with 0 and then 2. v of t dt. Now we're going to type in this into our calculator. So we're going to have map 9, 0 to 2, y1, dx, and plus the initial position, which is 8. So we got 8.369. So the position of the particle at t equal 2 is 8.369. This is how much you have to show. Part D. Find the average speed of the particle over time interval. So now let's recall what we learned before. Let's recall. If you remember, you can do it directly. So we say average of f of x on interval a to b. It means to integral a to b, it this f of x, you have to put f of x inside dx over b minus a. Average of f of x, so integral of f of x. So now here, average speed basically means the average of speed on the interval 0 to 2. So that means we're going to use integral 0 to 2. You put speed in here, and then 2 minus 0. What function is the speed function? We reviewed that before. So that means integral 0 to 2, absolute value of v of t dt. Speed is the absolute value of v of t, and then divide by 2 minus 0. So you just show this part. Now we're going to use our calculator. So we're going to do a math 9, 0 to 2, and we are going to put the absolute value, math num, okay, 1. So this is going to be our numerator, and the denominator is 2, so divide by 2. So we do it together. So we got 0.371. So the average speed for the particle over the time interval 0 to 2 is 0.371. So you only show this much. All these are behind the scene. You don't need to write this, you don't need to write this. Now let's take a look at part E. Is the speed of the particle increasing or decreasing at t equals 4? Give a reason for your answer. The speed increasing, decreasing, or it means speeding up or slowing down at t equals 4. So we learned that we need to use both the velocity and the acceleration at t equals 4. If these two have the same sign, the object or the particle speed up. If these two have the opposite sign, then the particle is going to slow down. So now we're going to put v of 4 and a of 4. Let's find out, okay, how much is v of 4. So we already know that this function, it means the v. So we go back to the main screen. We do the y1 of 4. y1 of 4. So we got 1.946. And then we already found the a of 4 from part 8, which is 0.714. Now we say that because both v of 4 and a of 4 are positive, they have the same sign. So the particle will speed up at t equals 4. In other words, the speed is increasing at t equals 4. So try to use the same vocabulary that was given in the question. Now we finish question number 2.